Greetings and welcome to Talk a Little, Learn a Lot, the American Society of Naval Engineers podcast. I am your host, Stephen Phillips. In this podcast, we talk a little and learn a lot about naval engineering while inspiring the next generation of STEM professionals. Today, I'm joined by Dr. Robert Stone, commonly known as Dr. Bob, and Cara Johnston of Virginia Tech University, to discuss the International Submarine Races to be held at Naval Surface Warfare Center Carderock from June 23rd to the 27th of this year. If you have not heard it, I recommend listeners go back to episode 26 to listen to my discussion with the ISR race director, Jerry Rovner. Dr. Bob, Cara, thank you for joining me on the podcast. I look forward to this discussion. Let us begin with each of you, please, introducing yourselves and your role for the Hokie team.
Hi, I'm Bob Stone, as my students call me Dr. Bob. I'm a professor at Virginia Tech of biomedical engineering. After 6 years in the nuclear Navy in the 1960s, I came to Virginia Tech, where I did my undergraduate, master's, went off and got a doctorate, and came back and taught in mechanical engineering for a couple of years. Then I went into industry for 39 years and returned 3 years ago so I could share some of that industry experience and help with the students. I am the faculty sponsor for the team. I love meeting with the team and sharing the background that I have, in Navy, in diving, and general engineering, in helping them to succeed in their challenges of building submarines and working in their senior design capstone projects.
Hello, my name is Cara Johnston. I'm a current senior in mechanical engineering here at Virginia Tech, so wrapping up my undergraduate, and I will be completing my degree in May. I currently serve as the team's president, so essentially what that means is I oversee all of the administrative side of the team, work directly with our head of design, on designs and functioning and scheduling testings and really just constructing the entire team. I'm also a part of our senior design team this year. So we're an interdisciplinary capstone project here at Virginia Tech. So currently, right now, we're working on developing autonomous controls for the submarine and also the entire drivetrain system. So very excited to be part of the team. I've been a part of the team for the past 3 years. So been a great experience this past year stepping into that president role and being able to lead our roughly like 50 to 60 person team this year.
Dr. Bob, please give us an overview of the International Submarine Races and why Virginia Tech participates.
The International Submarine Races is a competition that's held currently every 2 years between various groups, usually students, although there's some individuals involved as well, designed to inspire competition that gets people interested in marine engineering and its aspects, to learn the various tasks that need to be performed, mostly to get excited about, hey, this is fun. I can do this. I've heard it said that if you enjoy what you do, you'll never work a day in your life. And I tell my students, that's a lie. You will work harder every day in your life because you'll enjoy doing what you do. So the group that we have typically that are students design and build these. They're entirely human powered. They don't get to use any stored energy, and they race 100 yards. There's a number of categories in which they can win, including speed, design, team coordination, novelty, other categories. So it's a wonderful way to get young people interested in something that can benefit them for the rest of their lives.
How did you first become involved in the International Submarine Races?
Oh, it's kind of interesting. I was working with the former advisor for this group in helping design an electronics lab that would be interesting to biomedical engineering students. He decided to move on to something else, and I guess he knew a bit about my naval background and asked me if I would be interested in advising the group, and I jumped at the opportunity. Just love almost everything about marine engineering, naval engineering, even though my primary category is electronics and medical devices. There's an awful lot of overlap in every engineering field. So I met with the HPS, Human Powered Submarine Leadership Team, and was invited to assume that role, and I've enjoyed working with them ever since.
Can you unpack your role in more detail? Like, what exactly do you do for the Virginia Tech team?
Well, I meet with the leadership team at least once a week, help keep them on schedule, teach them the techniques of doing a professional type organization, planning things out and then working the plan, doing the design in a documented fashion where you actually review it, build it, test it, do the redesign, and then contribute some engineering knowledge and little things that I've worked on in the past that do work and that don't work. Uh, how can we make this a bit simpler? How can we make it stronger? How can we follow in the path and learn from our mistakes, but plan on success? Make a plan and work the plan, and we will succeed.
Virginia Tech indeed has an illustrious ISR history. I've gone and looked at the website. I've noted the Hokies started with ISR 3 in 1993 with Phantom, and then ISR 4 with Phantom 2. The team won overall in the sixth ISR with Phantom 3. That was in 2001. Then came Phantom 4 and Spectre 1 for ISR 7. Phantom 5 followed. Phantom 5 was a real workhorse. From the website, it looks like it participated in ISRs 8 through 11. Phantom 6 raced in 12 and 13, joined by Phantom 7 and 13. Phantom 8 was in ISR 14 and 15. Trident also joined for ISR 15. And then Nautilus for the virtual ISR 16 and ISR 17. Kraken also raced in ISR 17. Is that the boat that's currently prepping for 18, Kraken?
No, it's not. There's a whole new boat that's being prepped for this next race. So it's got some nice new features to it, including autonomous navigation control system with an interesting emergency cutout so that the pilot can take control immediately. A new type of drivetrain that they're trying to get more robust than what they've had in the past with their drivetrain. You don't plan to fail, but you plan how to respond if there is a failure. So we're doing our very best this time to make it much more robust. The concept of this autonomous drive is the pilot is going to be able to focus entirely on pedaling unless there's a problem with the autonomous controls. So it'll maintain depth, trim, and stay on the path and let the pilot just pedal away as hard as he can in order to try to win the race.
That'll be really interesting to watch. Cara, can you tell me how the team is formed?
Yes, definitely. So here at Virginia Tech, we are a registered student organization. So we essentially operate just as all the other 800 student organizations operate here. So we typically do our big recruiting process in the fall. So there's big events here on campus, one of which is called Gobbler Fest, where we go out on this big green space on campus. We recruit, we bring all of our subs out there, we bring dive gear, tons of different stuff to get people excited about the team, get them interested in the team, and really just try to recruit and get as much interest as possible. And then from there, we have an application that we send out. Usually get some applicants back. From there, we'll narrow it down. And then we have a secondary interview process. And then after that, we admit people to the team. They come in, jump right in. We try to get people involved as quickly as possible, get them on projects, get them that hands-on experience so they can really hit the ground running and become valuable members of the team in a short period of time. So we have a small recruiting process that happens during the spring semester as well, but we primarily recruit in the fall and try to get as many people as we can. So right now we're currently sitting at around probably 50 to 60 members in total, which is one of the bigger teams in recent history, but it's been really awesome to see that many people in the lab coming and doing work and all of those great things.
Dr. Bob talked a little bit about the design, but I'm interested from your perspective. What is the inspiration for the team's current submarine design for this approach?
Definitely. So we definitely took a lot of inspiration from previous submarines, specifically last year, or 2 years ago in ISR 17, Kraken, which you had mentioned earlier. We were happy with Kraken, but definitely wanted to improve upon it coming into these races. Specifically, Kraken was a very, very small sub. The only pilots we could kind of fit in there were like my size or smaller. And I know you all can't see me, but I'm, like a 5'4", pretty small person. So we really for this design, wanted to make a larger sub to be able to fit a lot more. And as Dr. Bob was talking, kind of trying to integrate autonomous controls, a more robust system overall, we needed that space. So this sub is pretty significantly larger than Kraken was, but that's been enabling us to put much larger pilots in there, a lot more robust systems. We've also had a focus on kind of more modular design, design for assembly, design for manufacture, to try to make our lives a little bit easier. If stuff breaks, we can take components out a lot easier. We can assemble things quicker and easier as well. So really just trying to continue to improve, look back on past documentation to try to make the best sub that we can heading into these races.
Could you walk us through the design and construction process of your submarine?
Yeah, so as you mentioned earlier, ISR is every other year. So that means that we operate on a 2-year kind of design, build cycle, everything like that. So typically in recent years, we have been completely making a new hull and manufacturing an entire new sub every single design cycle. So what we kind of start with is just start with like initial size constraints. Typically in recent years, we've been doing single pilot subs, might venture in the world of two-person subs in some new years, but usually single person. So really start with those size constraints, an overall general arrangement of subs, like where do we kind of want controls, where do we kind of want the drivetrain, and then from there use MATLAB, SolidWorks, Star CCM, all of those great tools to design holes and run flow sims on those holes. And once we have that shape, we we translate it from CAD into actual manufacturing. We use tooling board. We glue it all together. We have sponsors that will go mill it down to that shape for us. Then from there, it's just whole manufacturing. We use a lot of fiberglass and just epoxy resin to manufacture that whole. And then as that is all going on in that side of that manufacturing, the rest of our team is working on designs for the drivetrain, controls, all those bigger projects as well. So that's kind of in a nutshell how we design and manufacture the entire submarine. And specifically right now, kind of in this last semester leading up to the races, a big emphasis on testing and just trying to get as much test time as we possibly can. So we've been testing a lot this semester. Actually, I had a test this morning. So, and go to test and break things and see what happens and see how we can make the best sub possible.
What are some of the key engineering principles that you have applied?
I think the biggest engineering principle that I've applied during my time on this team is just kind of the entire engineering life cycle. I'm being able to go through that entire process. So specifically, we start with just concept generation, being like, what could we even do? We usually write out like our needs, our wants, stuff like that for different components. And then concept generation, low fidelity prototyping, testing, validation, just being able to go through that entire engineering life cycle has been really interesting. And I think being able to apply, we learn about that in class, kind of what that whole thing looks like, but then being able to apply it has been really awesome. And then some of those other engineering principles, just we use a lot of like CAD, coding, flow sims. It's kind of more of those tools, but definitely just trying to understand what a system will do, what we expect it to do, and just trying to like understand a lot of problem solving as well, and definitely kind of on the spot problem solving is a very, very big one too.
It reminds me of the title of this podcast, which is Talk a Little, Learn a Lot. It's an homage to Rear Admiral Wayne Meyer, whose principle was build a little, test a little, learn a lot. So, yeah, interesting.
Mhm.
What were some of the biggest engineering challenges you've faced so far, and how did you overcome each of them?
So kind of building off of, I just talked about testing and how that's a big thing. I think most of our problems occur the second we put something in the water. It happens quite frequently where stuff works perfectly on land. We dynamically test it on land, statically test stuff on land, and the second we put it in the water, things break in ways that we would never expect them to break. So specifically this semester, there's been just weird stuff that happens when we start putting stuff in the water. And a lot of that happens during our pool testing time, which is very limited. It's been very tricky for us to find locations to test recently. So stuff arises during testing. That's just that on the fly problem solving to figure out how we can come up with a quick solution, figure out something to work so we can still have a good pool test and really take advantage of that pool testing time that is so precious and limited. Specifically this semester, some of those big engineering challenges we faced, a lot of it's been with the drivetrain, and a lot of that's just been kind of gear meshing issues. We have a combination of a chain going back to a bevel and pinion gear set for this new drivetrain. So there's been some weird things with gear meshing, making sure the chain's at the right tension, and a lot of that stuff we've tried to dynamically test, but a lot of those issues don't pop up until we put it in the water. So that's been definitely one of the biggest ones recently. It's just really taking that testing data and then figuring out what to do with it.
Cara, I'm interested in some of the specifics and wonder, can you talk about some of the hydrodynamics of your design? I'm also interested in what else might make the Virginia Tech boat unique. I heard some from Dr. Bob about the autonomy piece, but are there other elements that are unique that you can share with the audience?
Definitely. So, speaking on the hydrodynamic side, we've definitely put a lot of work into flow sims and all of that type of stuff. Specifically, this year, in our second year of our design cycle, we've been focusing on our propeller design. And additionally, we added something called the tail cone. We're calling it the tail cone towards the stern of our submarine to help with kind of the inflow velocity to ensure we're getting the optimal inflow velocity into the propeller as possible, and using a lot of flow sims, MATLAB, open prop code, stuff like that to be able to design our propeller to be as optimal as possible to meet our design speed. So I think on the hydrodynamic side, just kind of all that time we've invested in those flow sims will really help pay off. Our testing today went very well, so kind of starting to see all of that pay off. Especially that tail cone has really helped. The sub looks very hydrodynamic now with the addition of that tail cone, and it'll definitely help us reach our goals there. And as far as submarine being unique in the water, Dr. Bob talked about that as autonomous controls, which definitely is unique. One other big aspect is we have a very updated electronic system for the sub, including like a pilot heads-up display that will tell them their heading, depth, RPMs, how fast they're going, if they're steering off course, what they need to do to correct it, and just a really robust electronic system, which has been a really big improvement for the team and has been really cool to see.
What materials have the Hokies been using, and why were those choices made?
Definitely a lot of different materials being used to make the sub. So our entire submarine is mostly manufactured out of fiberglass and epoxy resin. We usually make that choice just for cost effectiveness, ease to work with. In previous years, like 10 plus years, way before my time, we had some carbon fiber holes, but moved away from that just for cost and different things like that. We do still use a little bit of carbon on our propeller, stuff that could get hit where we want a little bit more of that structural integrity. As far as internal components go, we usually use a lot of aluminum. We do a lot of in-house machining. Almost every single thing inside our submarine is machined in-house by students like me and other people. So we do a lot of aluminum just for ease of machining. We have some steel, but that was one case where we very much learned from past mistakes. Kraken, the submarine we mentioned earlier, a lot of that was done with stainless steel, which was very, very hard to machine. So definitely learning on that, using aluminum, kind of some of those easier machinable materials wherever we can.
Dr. Bob, can you describe what unique designs, perhaps what chances the Hokies have attempted in the past?
Uh, I can only address the last couple of years as to what they've attempted, but they were really trying to get this autonomous control system going uh, in order to enable the pilot to focus all of his energy. We discussed just how much difficulty it can be. Being an aviation pilot, I know how difficult it can be when you can't really see out what's going on. And that's the case in the submarine. You can't really see what's going on very well at all. You're trying to pedal and you're trying to maintain your depth. You're trying to maintain your heading. So an autopilot is almost always the thing that saves your bacon when you're flying in IFR. And when you're in these uh, tanks or in your pool, you're flying IFR underwater. So we're trying to encourage the students to get this going and enable the pilot to just concentrate on keeping the sub going straight. So that's been a challenge. They've recently dealt with trying to get a low noise signal from their inertial guidance system and trying different techniques. One of the things I try to communicate to them is they need to follow Occam's razor. The simplest solution that works is the best solution. They often leave out that works. So that's been a challenge getting that going, but I think now they're winding it down into the final phase. One of the other things that was a challenge was, what if the autonomous control system fails? They did a great deal of work in determining how much force would be applied with the planes so that the servo motors would be adequately strong to actually control the depth and the direction of the submarine. And it worked great until they ended up attaching the disconnects. And the disconnects had enough force on them that they were now requiring a change in their disconnect feature so that it had little to no force on the system until you actually disconnected and had them enabled. So challenges rise up. Very interesting solutions that the students have come up with, quickly iterated and came up with designs that would work. So trying in between a shaft type drive versus a chain drive in order to have the least room, the least interference with the pilot's legs. These are challenges to get the ergonomics just exactly right and to be able to adjust between different sized pilots. You're not necessarily going to have the same guy going to get in that or girl get into that submarine. So coming up with a rapidly adjustable system, those are things that they're working on, and they've come up with some very unique and useful solutions. So I'm really proud of the way they're hanging in there, recognizing the problem, and then coming up with solutions that would address it instead of having to go out and find a bunch of people that are all the same leg length.
And I'm interested, what is your approach in guiding the team as the faculty representative, as the coach?
There are several different things. One is I encourage them to document everything as they go along. It's one thing to be a technician that's just cut and trying things. It's another thing to be an engineer where you literally look at your design, you sketch it up, you go through the process, as Cara mentioned, of they're actually taught to go through this rough prototype. Does this even look reasonable? A benchtop prototype, and then actually putting it into the device and then testing it in water and understanding what the differences are going to be. So we try to make sure they follow the design process each time. I encourage them strongly to come up with a project plan without going into a particular company's project plan, but have a documented project plan with a Gantt chart and review that each week. Where are we? Are we behind? Are we ahead? How do we catch up if we're behind? If we're ahead, how do we apply these resources to something else? So just reminding them that it's all a team effort. And if one group is ahead and another's behind, you redirect your resources along the way. Spend a lot of time as a CEO. And while I'm not a CEO of the team, I know what to remind them of the things that they need to accomplish in order to be effective. So encourage them to mark down, to write up their failures as well as their successes. I kind of wish in the professional publication world that we would have publications of what doesn't work instead of just the ones that we think do work. We learn much more from what doesn't work than from what does. So that's what I try to communicate over the many years of experience of how you successfully complete a project and convey that to the students so that they're in charge and they get it done.
Cara, can you describe how your team collaborates?
Definitely. So there's a couple different ways we ensure we're communicating, getting all the important information across. So the biggest way that we collaborate, make sure we're talking to each other. We have one big group chat where everyone's involved. We use different messaging softwares like Teams, essentially, to make sure everyone knows what's going on. We can split it up by our different sub teams, different events we have going on, and that's a great way we can talk about ideas. We don't all necessarily have to be in the lab, but we can talk ideas through kind of online ways. And then we also have very fortunate to have a really great lab space on campus where we can go talk. We have tons of different whiteboards. We're always drawing different ideas, talking out different ideas, being, hey, I think that's not going to work, or that's going to work really well, and we should go along with that. So constantly talking. That's one thing I really love about this team is the amazing culture we have. And I feel like everyone feels like they can have a voice, can talk, can speak up, can share their opinions, ideas, everything. And so it's a really collaborative environment. We're all trying our best to make it as best as possible. And even if people aren't necessarily exactly on a specific project, they're still giving their ideas, seeing problems that may happen, different things like that. So we're all constantly talking. There's never a quiet moment in that basement. So we're always talking to each other and always communicating, which I really love about our team.
What are the different roles and responsibilities that you have on the team?
Yeah, so I think I talked a little bit about it earlier, but there's a couple different ways how our team's organized. So we're essentially split into kind of two sections. We have more of our officer admin side, which is myself, president, and then we have a couple different officer roles listed like treasurer, sponsor relations, our VP, different things like that. And then on the other side of the team is more of our technical side. So we also have a head of design, and then underneath the head of design, we organize our team by different sub teams. So we have an electronics sub team, control sub team, structures, and then a hydrodynamics sub team. So that's kind of how we're split up. And then within each sub team, our just kind of general team members can choose a sub team or multiple to join. If they really want to focus on different specific parts of the submarine. So our LEs, our lead engineers, are in charge of each sub team. And so their kind of roles, responsibilities, they take in all of their projects, they delegate those out to different team members, and then they're to act as a guiding presence, help out people if they need it, help CAD or help prototype, or be like, hey, have you thought about this? Oh, remember to fill at that corner so we don't create a stress concentration. Just like little things like that to be a good guiding resource for our general team members. And just that's a little bit of how our team is organized. And then we always just try to communicate, talked about that collaboration. We really just try to make sure everyone's hearing everything along every single step of the way. So, very much like how our team's organized, I feel like everyone kind of knows their roles, knows their responsibilities, and it's been really effective in making sure we're getting things done on time.
What's been the most rewarding aspect of participating in this project?
Man, there's almost too many to name. This has been truly the highlight of my college experience so far. I think recently, definitely the most rewarding aspect has just been seeing it move across the pool effectively, not making weird sounds, and seeing something that I've poured my heart and soul into for the past 3 years, finally pay off, and being able to see that and visually see it is incredibly rewarding. And being able to do it with some of the most amazing people in my life. I've met my best friends on this team, and I being able to share those moments with them where we see the sub go across and we're all like dancing, clapping underwater and everything, which has been really awesome. And then another really rewarding part of this project is just outreach with the community. We're fortunate enough to be able to go out into the Blacksburg, Christiansburg area, talk with kids. We do a lot of stuff at schools, events on campus where people can come in, learn about the sub, and it's been really awesome to talk to people about what we do and get them excited about careers in engineering, whether it's marine based or not. It's been really cool to talk to them and see kids kind of like light up a little bit when we start talking about the sub, or like put kids in the sub and have them like pretend to pilot or like move the joysticks or spin the drivetrain, and seeing them interact with it directly has been incredibly rewarding as well.
Cara, what advice would you share for those interested in competing in ISR in the future?
I definitely think my biggest piece of advice would just be test as much as possible, test more than you think is necessary. Even if it seems excessive, test as much as possible. I think I mentioned earlier that there's problems that you don't think will arise until you put it in the water. So just find those opportunities for in-water tests. I know firsthand it can be really hard to find those opportunities, but if you have those opportunities to really do that testing, do it as much as possible. And then my other big piece of advice would always just try to keep the big picture in mind. I think a lot of the times on our team, everyone very much focuses on their project, which as they should. They're given that project, everyone takes ownership of it and they really embrace it. But it's always good to take a step back and really see things as a whole picture, because sometimes it's very easy to overlook little things, being like, oh, that clip's gonna run into the pilot's feet. And then you like don't really think about it until it's all in there and you start looking at things. So really just trying to keep big picture, remember system integration and trying to keep everything all has to work as one and trying to keep the big picture in mind, especially in a confined space. So we're pretty limited space on the interior of the sub, so trying to keep all of that in mind as well.
Dr. Bob, what do you hope students take away from participating in this competition?
Well, first of all, I hope they take away the whole concept that teamwork is successful, that different people doing different jobs, covering for each other. Frankly, having worked in 3 startups in my life, if you can be a utility infielder, you're going to have a whole lot more opportunities in life as opposed to specializing in just one thing. Being able to help your fellow team members do the tasks that they need to do. That gets emphasized. They do the work, they succeed together. Competition, the idea that we would really like to win that competition. How well can I do this job? And even competition within the team can be effective. Friendly competition, as works on sports teams, friendly competition for position, for roles. It ends to success. Thirdly, participation in real engineering efforts can help a person find a profession that is truly rewarding and profitable. When you succeed, you like doing what you're doing. And to be able to find what you really enjoy is so important. And then participating in a program like this can lead to really good job opportunities. The students get to meet mentors from other groups. They find out what is necessary to achieve success. They learn to communicate effectively with others. It just helps so much as they start their career. And hopefully, the main thing they learn is you can succeed. Some people come in not having succeeded before, but now they're able to do something and succeed. So those are just some things that they take away. And frankly, work can be fun. Absolutely can be fun.
What advice would you give to students who are interested in pursuing a career in naval engineering or related STEM fields?
Learn all the science that you can. How does stuff really work? Not that you're trying to find the theory, because frankly, the theory came after the device was observed working in the first place. So observe how things work. Learn and learn to apply it, link things together. My children growing up used to hate it when I would say, widen your correlator, which really means this stuff you learned over here applies to the problem you're trying to solve here, even though they don't look like they're related. And this is really true for a project like the human-powered submarine. All the stuff you've learned in the past. When students come to my office, it is just stuff full of gadgets, all kinds of things. And I love to put one of them in front of them, explain to me how this works. One in particular has 5 different forms of energy. And I said, tell me all the forms of energy this has in it. Because I want them to want to know, how does stuff work? If they take that away with them, then they get out on the water, do things in the water, observe things in the water, get a scuba certification, which, by the way, a number of the students come into the program and they end up getting scuba certified. We have a scuba shop that helps supply all the supplies necessary, teaches the students. You can learn to be the person that has the idea that's the aha moment. I want them to have that. I want them to love to learn going out of it. And when they do that and they go in and they apply for a job, their enthusiasm in solving the tasks that are put before them in job interviews will lead them to success, period.
Where can our listeners learn more about the International Submarine Races and Virginia Tech's engineering program?
Well, first of all, at www.internationalsubmarineraces.org, you can look at the various races of the past. There's lots of pictures, there are descriptions of everything you need to know in order to get involved, or even start a group that would get you involved. If you want to see what we're doing here at Virginia Tech, there's www.hps.aoe.vdu that you can go to and see what we're doing here and learn how to get involved.
Cara, I have one more question for you.
Mm-hmm.
Does the team play Enter Sandman as they launch the submarine?
So So they do. I remember I unfortunately couldn't go to last ISR 17 because of an internship, but I do remember they through the underwater sound system they played Enter Sandman as we were launching the sub, and our new sub's name is actually inspired from Enter Sandman. So we kind of we took the first two letters of exit light enter night and smushed it together for our new sub's name. So we'll be racing a sub named Exlieni in ISR 18.
Right on. For those who are not witted to this, the Hokies always play Enter Sandman by Metallica for their football team whenever they take the field. It is a sight to see. If you go on YouTube, you can find videos of it. It is unbelievable. Dr. Bob, is there anything else that you would like to share with the ASNI audience?
Yes. If you're out there in industry, or if you just want to see young people to continue to develop the skills that would enhance our abilities in exploring the most unexplored part of the earth, contact us or your local university or alma mater and either donate time or funds to support these organizations. If nothing else, come to the expos that they have. Encourage the students. The students learn real life skills, including electronics, machining, welding, design documentation, materials fabrication, industrial safety, and on in this process. Many become scuba certified and go on to jobs in marine engineering or other support areas. They become the kind of employees that work on their own time to succeed at their tasks.
Well, thank you, Dr. Robert Stone and Cara Johnston, for taking this time to discuss the Virginia Tech team's entry for the 2025 International Submarine Races. I hope that we can welcome you back again sometime to talk a little, learn a lot, the podcast of the American Society of Naval Engineers.
Thank you, Stephen. It's been a pleasure to talk with you this afternoon. I hope we inspire others to look at this as a really challenging field to get into that is rewarding beyond description.
Thank you so much for having us. It was great talking with you today.